And I need to address one important point here, and that is the so-called Fermi paradox, which many of our folks in our community are aware of, and that's the idea of, well, if we're relatively late to the game in terms of the galaxy creating complexity, and there's some evidence that we are, why haven't we seen all these other intelligences that came before us? Well, if we live in an evolutionary developmental universe, and if we're all going to discover relatively soon that inner space rather than outer space is the direction that intelligence goes, what's called transcension rather than expansion, and if we learn that the reason that we're all so separated from each other is so that we can all come up with our own unique evolutionary solutions, so it's kind of like a buffer, it's like a boundary that's been built, right?
Kind of a built-in prime directive almost.
Exactly, a built-in prime directive to say that because none of us are going to be gods at the end of that. We're all going to be interesting superpowers, to use your phrase, right? And we want to then go on and create something even cooler. Well, then we would not send out an Encyclopedia Galactica or a replicating robot probe or anything like that on our way in, because if we did, every other organism, every other intelligence that got that information would be condemned to go down their hole in the same way we did. And we would take all the evolutionary variation out of the system. We would end up meeting ourselves on the other side. And every time that happens in biological systems, the clonality that emerges is a far less resilient system than a system that has a lot of evolutionary diversity in it. So what you find is that systems that maximize evolutionary variation, maximize their adaptation, and you might expect, if people love the idea of exploration, and there's people who are very interested in futurists that we know who are very interested in space colonization, and so you might expect that there would be some people who would try and resist that, and occasionally that might occur. And so if you look closely at the galaxies that are out there, we might find one or two or a very small number of them that had managed to somehow subvert that developmental directionality. But statistically, that doesn't happen very much in developmental systems. It's very rare. So developmental systems can undergo failure, like spontaneous abortions, for example, in development of a complex organism like a human. But they happen very early in the system. There's lots and lots of them in the first few days and weeks. And then there's far less of them the more complex the system gets. So the developmental system becomes more self-regulating. The immune systems get better. The kinds of failures that occur are much more specific. And it's, to me, quite plausible that statistically there would be this prime directive, to use your terms earlier, that pretty much makes all complex organisms discover that they're here to maximize their understanding, to maximize their creativity and evolutionary exploration, and that they're also chained to this developmental future, that some point or other they're going to go in to inner space and they're going to meet others like them, and they're going to, in that situation, be able to take the knowledge they've gained and do something even more interesting with it. So there's a lot of there's a lot of speculations in this model, but some of them are testable. And one of the interesting ones is, which I published an article on it in 2003, it's called Answering the Fermi Paradox. And it's basically the idea that our SETI, our search for extraterrestrial intelligence, should get good enough in the next few decades for us to be able to discover a non-random electromagnetic radiation coming off of planets that might support intelligent life. So the kind of stuff that we've sent with our radar and our radio and our television broadcasts over the last 50 or so years. And we should be able to discover a good deal of that in other locations, anywhere that there's an intelligent civilization. And like I said, maybe there's 10, maybe there's 100, maybe there's 1 million, like Sagan said, the upper limit of what we might have in our galaxy. Now, any fraction of those that where we discover them in that narrow period where they're sending off unintentional electromagnetic radiation, they're kind of an early intelligent civilization. Well, in my model, shortly thereafter, they would all go through their technological singularities and then go into inner space, go into basically the realization that their developmental future is to go eventually and merge with all these other intelligences and do it in a way that maximizes as much evolutionary variation as possible. So what we should see, if that model is true, is the winking out of all of those unintentional electromagnetic radiation broadcasts at a nice regular level everywhere that we look, everywhere that we find them. So it's one of the models one can imagine, one of the conjectures of the hypothesis that seem testable. And again, it feels to me intuitively like this is something like that is really what is happening. But I'm just one person, and the EvoDevo universe community has many different people who have different perspectives on what kinds of evolutionary or developmental processes may be going on in the universe. For me, understanding accelerating change from a universal perspective, understanding how it might be developmental, is a key question, and that's what's led me to this particular model. And there's probably one last thing I should say that is interesting evidence, I think, for this, and that is in developmental systems, biology, very rarely do you see positive feedback or sustained acceleration. And where you see it, it's almost always associated with replication. So the processes in a developing organism that lead to the emergence of hierarchies of complexity that take you to replication, that's all accelerative. So if you and I want to replicate ourselves, if we're an organism and we're about to die, well, we have to do a whole series of accelerative things. First, we have to go through a courtship, and there's a bunch of interesting accelerative activities that happen in a courtship and mate selection. Then we have to go into some kind of a copulation. Then we have to fertilize the egg, and then the egg has to go through an acceleration. But the female that we would, as metazoans, that we would copulate with, for example, they have a monthly acceleration in primates every 30 days to create the so-called Graafian follicle, which is the single fittest egg, which goes into the fallopian tubes, and is then ready for potential fertilization. So a whole series of sustained positive feedback kind of chemical competitions amongst these potential eggs for the one fittest egg to pop out. And like I said, most of what happens in biology is negative feedback. The system is kind of balancing itself, and you don't see these sustained accelerations. But you see them all the time in replication. And if our trending into this black hole type of a thing, this transcension thing, maybe it never is a black hole, maybe it's some other kind of transcension, but if our trending into this inner space where we then are able to meet with these other intelligences is an accelerative process, well, replication is the most obvious developmental model that, for me, would explain the acceleration. That, yes, each of them is going to take a completely different, unpredictable path toward that replication, and there's going to be a lot of interesting, unique knowledge in those individual paths, evolutionary paths, but at the same time, you have to have the cycle or you don't perpetuate the complexity, at least if it's a developmental system. And so the kind of things that I hope over the remainder of my career, will be questions that will be answered, or if not answered, at least we'll be able to critique these models better and hopefully come up with other even better models that we aren't even yet imagining today for what things are predictable and what things are not predictable in this amazing complex world we call the universe.
Well, it's certainly a series of better understandings that we have to look forward to. I just have to say that I love that imagery of looking out and hearing or listening to the world, to the universe around us, getting silence in return, and potentially finding that as an encouraging sign. To think that we might look at to observe these civilizations apparently disappearing and know that that's an encouraging sign that we might one day meet them over on the other side.
Thank you. Yeah, I think there's some early evidence in information theory that the way you build complexity is two-way communication. And if we have a future information theory that can tell us that you need feedback, you need two-way communication in order to build complexity, and sending a one-way message is actually going to destroy complexity unless it's part of a developmental control process. There are situations in development where one-way messages do occur, but from an evolutionary perspective, complexity construction doesn't seem to benefit at all from one-way messages.